right, guys, here's part 2. We're looking at example number 3. Trying to solve this 3-variable system. When I look at it, I don't see anything that lines up that would cancel out. Like x variables, coefficients are all different, the y's are all different. So I think the easiest thing to do, because this has got a coefficient of 1 up here, I'm going to solve this system for y. What would I have to multiply this equation by to cancel out that positive 3y? Hopefully you said positive 3. So 3 times 2x minus y plus 3z is equal to 5. And then we're going to leave the second equation alone. I think we're going to end up with a big bonus on this one. All right. So that's my first two equations. All I did was took the first equation, multiplied it by 3. Let's actually multiply this out. I get 3 times 2 is 6x. 3 times negative y is negative 3y. 3 times 3z is 9z. 3 times 5 is 15. And then my second equation is negative 6x plus 3y minus 9z is equal to negative 15. What happens when we add those guys together? The x's cancel, the y's cancel, the z's cancel, and the 15's cancel. And I get the equation 0 is equal to 0. So at first glance, you're like, well, that's not very helpful, Miss Harris, but it is. Does 0 equal 0? It always equals 0. So it looks like, to me, this is going to be all real numbers. I need to test one more set of equations because we haven't figured out if this gives us the same answer. So let's do the same process, but this time we are going to try to get rid of our x's here. So I'm going to look at this equation, first one, and the second one. What would I have to multiply times 2 to get rid of the 4? I'd have to multiply it by a negative 2. So negative 2 times 2x is negative 4x. Negative 2 times negative y is 2y. Negative 2 times 3 is negative 6z. Negative 2 times 5 is negative 10. Keeping the second equation the same, what do we get rid of? When we add these guys together again, my x's cancel, my y's cancel, my z's cancel, my 10 cancels, and I get 0 equals 0. So what this means is it doesn't matter what we plug in for x, y, and z, we will get a point on our graph. Sorry, not no real solutions. It always works. 0 is always equal to 0, so all real numbers. So these are actually just one line. All three of these are the same line. They just are multiplied by a different number in the front. So all real numbers for 3 are solution there. Looking at number 4. The first one's solved for x. So let's try substituting that one in for x here and for x here and see what we get. So I got minus 5y plus 4z plus 1. That's what x is. Minus 2y plus 3z is equal to 1. And then I've got 2 times minus 5y plus 4z plus 1 plus 3y minus z is equal to 2. All right, let's simplify that. Let's see, I've got negative 5y minus 2y would be negative 7y. I've got 4z plus 3z would be 7z. Moving my number to the other side, I've got 1. If I move it to the other side, 1 minus 1 would be 0. Here I've got 2 times negative 5 is negative 10y. 2 times 4 is 8z. 2 times 1 is 2. So now I've got negative 10y plus 3y would be negative 7y. 8z minus z would be 7z. And then this time, if I move my 2 over to the other side, I've got negative 2 plus 2 would be equal to 0. Again, I come up with 0 is equal to 0. So this is another example of all real numbers being my solution. Because we came up with a true statement. So we will talk about these tomorrow. We've got lots more to work on these before we get to our quiz. Notice on the board it says your first quiz is on Friday. Do the best on your homework. I don't expect it to be turned in tomorrow because I want you to have a chance to ask me questions. It'll be due on Wednesday, but do your best with it and be nice to my sub, please.